Separation and purification. How is a mixture different from a pure substance? Mixture is made up of two or more substances that are not chemically combined, while pure substance is made up of one single element or compound. It is not mixed with any other substance. How do we obtain pure substances from mixture? The method we use to separate a solid from a liquid will depend on whether the solid is soluble or insoluble in the liquid. Have you ever brewed coffee from ground coffee beans? How would you remove the coffee ground from your coffee? Filtration is used to separate insoluble solid particles from a liquid. A solid can be separated from a liquid by filtration because the filter paper acts as a sieve. A liquid can pass through the pores or small holes of the filter paper, but a solid cannot do. Upon filtration, the solid that remains on the filter paper is called the residue. The liquid or solution that passes through the filter paper is called the filtrate. Evaporation to dryness is used to obtain a soluble solid from a solution by heating the solution until all the water has boiled off. The solid obtained by evaporation to dryness is not always pure. When all the water has been removed, any soluble impurities will be left together with the solid.
Have you seen crystals of salts? Crystals are made through a process of crystallization. Let us try to make salt crystals from a solution of salt. For this we need thread, a saturated solution of copper sulfate and copper sulfate. First we will make a supersaturated solution of copper sulfate. Light the spirit lamp, place the copper sulfate solution on the burner, heat the mixture. Now keep on adding copper sulfate till no more salt is dissolved. Fasten a thread on a support and suspend it in an empty glass. This thread will act as a nucleation center in the container. Now remove the solution from the burner. Pour the solution in the glass. Leave the glass aside for a few days. We see salt crystals formed on the string. This happens because the solubility of salt in water increases with temperature of solution, so more salt gets accommodated in the solution than it would have if water was at room temperature. This solution is called a supersaturated solution. The salt from this supersaturated solution gets precipitated out when the solution returns to room temperature. The salt molecules that get precipitated out start forming crystals at the nucleation center, which is the thread in this case. Crystallization is the process of formation of solid crystals of a substance by precipitating it out from a saturated solution.
How do we choose a suitable solvent for separating solids? Different solids dissolve in different solvents. The common solvents used in chemistry are water and ethanol. To separate a mixture of two solids, we use a solvent in which only one solid is soluble or the other solid is insoluble. Sublimation. It is used to separate a solid that sublimes from one that does not. Some substances, such as iodine, sublime on heating. Other substances, such as sand, do not sublime. Some metals, such as iron, nickel, and cobalt, are magnetic. We can make use of the magnetic property of these materials to separate them from mixtures. A magnet can be used to separate a magnetic substance from a non-magnetic substance. Simple distillation is used to separate a pure solvent or liquid from a solution. Distillation is the process of boiling a liquid and condensing the vapor. Pure water can be obtained from a salt solution by distillation.
This apparatus, the outer tube just hooks up to the water, so we get cold water running along the top, and then you can see the liquid condensing on the inside of the inner tube that drips down, and that's your distilled separated water. This is a distillation apparatus. What we have here is we have a round bottom flask that has a mixture of water and food coloring in it, and that we're going to heat using a Bunsen burner. And then over here we have some tubing coming out of a sink that feeds in right here, and that brings cool water along here, and then it comes out through this tubing and back down the drain. So what we're going to do is we're going to heat up this liquid solution over here, and then as we do that we're also going to turn on the sink. The So now we have water flowing from here through up into here. And what's going to happen is as this gets warmer and warmer in here, this is going to start to turn more and more into steam. That steam is going to come up here, and when it hits this particular part of tubing here, we have water running along the outside of the tubing that's going to cool down that steam and cause it to condense into liquid water over here, and then eventually we'll see that dripping start to come out through here. Going, and we have the water coming off of this because water is at a lower boiling point than the whatever the substance is that's used for the food coloring here. So we see the water coming over here in a much purer state than we have over here, and we can tell because this is colorless and this still has obviously the food coloring in it. So we're doing a separation here based on boiling points, and that's how this apparatus works. The trade-off with this is that it takes a lot of energy to boil the water. And so therefore, this is not a good means to do a separation on an engineering large scale. You can note here that you've got the steam, which you can't see, but then you can see it condensing into the liquid along here and then dripping down through here. If we were running the water through here, then it would really limit how much of this would turn back into this rather than just escape as steam here, and also limit the flow.
The method used for separating a mixture of two liquids will depend on whether the liquids are immiscible or miscible. Miscible liquids dissolve in each other, while immiscible liquids do not.
Separatory funnels are a necessary piece of equipment for many chemistry labs. These funnels are useful in separating two or more immiscible, non-mixing liquids. When using a separatory funnel, keep the following tips in mind. It is important to use a funnel that will hold twice the final volume of solution to be extracted and the extraction solvent. When adding the liquids, support the funnel with a ring stand and be sure that the stopcock is in a closed position. Add the solution to be extracted first, followed by the extracting solvent. Stopper the funnel and, while holding the stopper in place, gently invert and swirl the liquids. Do not shake the funnel as an undesirable emulsion may form. While the funnel is inverted, open the stopcock to release any built-up pressure. Close the stopcock and continue to swirl. Open the stopcock again to release pressure. Repeat these steps several times. When the liquids have been adequately mixed, place the funnel back in the ring stand and remove the stopper. Wait for the two liquids to separate. Open the stopcock to remove the bottom layer. Remember to close the stopcock before the top layer reaches the bottom of the funnel. Following these steps will make your extraction procedure a breeze. Please...
Fractional distillation. Fractional distillation is used for the separation of a mixture of two or more miscible liquids for which the difference in boiling points is less than 25 Kelvin. The apparatus for fractional distillation is similar to that of simple distillation, except that a fractionating column is fitted in between the distilling head and the RB flasks. Materials required: mixture of ethanol and water, 250 ml and 100 ml RB flasks, stand with lamp, fractionating column, distilling head, porcelain chips, thermometer adapter, water condenser, vacuum adapter, and heating mantle. Procedure: take a mixture of ethanol and water and pour it into a 250 ml RB flask. Take some porcelain chips and put it into the mixture. Now, connect a fractionating column to the RB flask and clamp it. Connect a distilling head to the fractionating column and a thermometer adapter containing thermometer to the distilling head. Connect a water condenser to the outlet of the distilling head and clamp it. Now, connect a vacuum adapter to the water condenser and a 100 ml RB flask to the vacuum adapter. Clamp the RB flask and place it in a beaker containing water. Now, connect a rubber tube between the inlet of the condenser and the tap to allow the cold water to enter. Connect another rubber tube to the outlet of the condenser to pour the hot water from the condenser to the sink. Open the tap so that water flows through the tube and fills the condenser and then comes out through the outlet. Set the temperature of the heating mantle and heat the contents of the RB flask. At 78 degrees Celsius, ethanol vaporizes and the vapors rise through the fractionating column and pass through the condenser, and condensation takes place and ethanol gets collected in the receiver flask in the liquid form and water is left behind in the distillation flask. Therefore, the separation of two or more miscible liquids for which the difference in boiling point is less than 25 Kelvin and can be done only by fractional distillation. Since ethanol in water forms an azeotrope, the distillation has to be repeated to obtain the pure components.
Food coloring is often used to color our food and drinks. Food coloring is a mixture of colored compounds called dyes. To separate the dyes in food coloring, we can make use of method called chromatography. Chromatography is the method of separating two or more components that dissolve in the same solvent.